Grounding electrical metallic tubing, or EMT, and metal boxes is a vital safety measure when working with electrical systems. According to the National Electrical Code, or NEC, all metal raceways and enclosures that house electrical conductors must be properly grounded. The primary reason for this requirement is to ensure that any fault current or stray electrical currents are safely directed to the ground. This prevents electrical shocks and reduces the risk of fires. When installing EMT and metal boxes on a basement concrete wall, it is important to adhere to these grounding principles. The NEC mandates that the EMT and metal box be connected to the building's grounding electrode system. This system serves as the primary path for fault currents to return to the source, tripping a circuit breaker or blowing a fuse, thereby cutting off the power to the affected circuit. In most buildings, particularly those with concrete foundations, the grounding electrode system typically consists of one or more components. One common element is a copper-clad steel rod that is driven directly into the ground. This rod provides a low-resistance path for electrical current to flow into the earth. Another frequently used component is a metal water pipe that is in direct contact with the earth for at least 10 feet. The metal water pipe must have continuous electrical contact to the earth to be considered a suitable grounding electrode. The connection between the EMT, metal box, and the grounding electrode system must be made using a grounding conductor. This conductor is typically a copper wire, sized appropriately for the circuit's amperage. The size of the grounding conductor is determined by the size of the circuit conductors, as specified in NEC Table 250.122. The grounding conductor should be securely connected to the metal box using a grounding screw or other approved fitting. It should then be connected to the grounding electrode system using a similar method. It is crucial to ensure that all connections are tight and free of corrosion to maintain a low resistance path to ground. There are several methods for connecting the grounding conductor to the grounding electrode system. One common method is to use a grounding clamp. The grounding clamp is attached to the grounding electrode, such as a copper-clad steel rod or metal water pipe. The grounding conductor is then securely fastened to the clamp. Another method is to use a listed grounding connector. These connectors are designed to provide a reliable and low-resistance connection between the grounding conductor and the grounding electrode. When working with electrical systems, it is essential to follow all applicable safety regulations and codes. The NEC provides detailed requirements for grounding electrical systems. It is important to consult the NEC to ensure that all grounding connections are made in accordance with the code. Improper grounding can create a hazardous situation. If a fault occurs in a circuit that is not properly grounded, the fault current can flow through unintended paths such as metal objects or even people. This can result in electrical shocks, burns, or even death. Therefore, it is crucial to ensure that all electrical systems are properly grounded to protect people and property from electrical hazards. In addition to grounding the EMT and metal box, it is also important to ensure that all electrical equipment connected to the system is properly grounded. This includes receptacles, switches, and lighting fixtures. Grounding these devices helps to prevent electrical shocks and fires. When installing electrical equipment, it is important to follow the manufacturer's instructions and all applicable codes and regulations. The NEC provides detailed requirements for grounding electrical equipment. It is important to consult the NEC to ensure that all equipment is properly grounded. Proper grounding is an essential part of electrical safety. By following the NEC requirements for grounding EMT, metal boxes, and electrical equipment, you can help to protect people and property from electrical hazards. Always consult with a qualified electrician if you have any questions about grounding electrical systems. They can provide guidance and ensure that all grounding connections are made in accordance with the code. The importance of grounding cannot be overstated. It is a critical safety measure that protects people and property from electrical hazards. By following the NEC requirements for grounding, you can help to ensure that your electrical system is safe and reliable. Remember to always disconnect power before working on any electrical system. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, consult with a qualified electrician. Firstly, grounding provides a low resistance path for fault currents to flow back to the source. Secondly, this path allows the overcurrent protective device, such as a circuit breaker or fuse, to quickly interrupt the flow of electricity, preventing a dangerous buildup of voltage. Thirdly, grounding helps to stabilize voltage levels, reducing the risk of electrical noise and interference. Fourthly, grounding minimizes the potential for static electricity buildup, which can damage sensitive electronic equipment. Fifthly, grounding provides a reference point for electrical circuits, ensuring proper operation and reducing the risk of malfunctions. In addition to the NEC, local electrical codes may also have specific requirements for grounding electrical systems. It is important to check with your local building department or electrical inspector to ensure that you are complying with all applicable codes and regulations. The grounding electrode system must be properly maintained to ensure its effectiveness. Periodically inspect the grounding connections to ensure that they are tight and free of corrosion. If you find any signs of corrosion, clean the connections and apply a corrosion inhibitor. The grounding electrode itself should also be inspected periodically to ensure that it is still in good condition. If the grounding electrode is damaged or corroded, it should be replaced. When installing a new grounding electrode, it is important to drive it deep enough into the ground to ensure good contact with the earth. The NEC specifies the minimum depth for grounding electrodes. The depth depends on the type of electrode and the soil conditions. It is also important to ensure that the grounding electrode is located in an area where it will not be disturbed or damaged. The grounding electrode should be protected from physical damage and corrosion. In some cases, it may be necessary to install multiple grounding electrodes to achieve the required grounding resistance. The NEC specifies the requirements for multiple grounding electrodes. The distance between the electrodes and the method of connecting them are important factors to consider. When connecting multiple grounding electrodes, it is important to use a continuous grounding conductor. The conductor should be sized appropriately for the circuit's amperage. The connections between the conductor and the electrode should be tight and free of corrosion. Grounding is a complex topic, and it is important to understand the principles involved. If you have any questions about grounding electrical systems, consult with a qualified electrician. They can provide guidance and ensure that your system is properly grounded. Remember that proper grounding is essential for electrical safety. It protects people and property from electrical hazards. By following the NEC requirements for grounding, you can help to ensure that your electrical system is safe and reliable. The grounding system should be checked at the time of installation. The resistance to ground should be measured using a ground resistance tester. The resistance should be within the limits specified by the NEC. If the resistance is too high, the grounding system should be improved. The grounding system should also be checked periodically throughout the life of the electrical system. This is especially important in areas where the soil conditions are corrosive. The NEC provides guidance on how to inspect and maintain grounding systems. It is important to follow these guidelines to ensure that the grounding system remains effective. In addition to grounding the electrical system, it is also important to ground metal objects that could become energized. This includes metal fences, metal siding, and metal roofs. Grounding these objects helps to prevent electrical shocks. The grounding conductor should be connected to the object using a grounding clamp or other approved fitting. The connection should be tight and free of corrosion. When grounding metal objects, it is important to follow the NEC requirements. The NEC specifies the size of the grounding conductor and the method of connecting it to the object. It is also important to ensure that the grounding conductor is protected from physical damage. In some cases, it may be necessary to install a separate grounding electrode for metal objects. The NEC specifies the requirements for separate grounding electrodes. The electrode should be located near the object and connected to it using a grounding conductor. Grounding is a critical part of electrical safety. By following the NEC requirements for grounding, you can help to protect people and property from electrical hazards. Always consult with a qualified electrician if you have any questions about grounding electrical systems. They can provide guidance and ensure that all grounding connections are made in accordance with the code. Grounding is not only important for safety but also for the proper operation of electrical equipment. A properly grounded system can help to reduce electrical noise and interference, which can improve the performance of electronic devices. In addition, grounding can help to protect sensitive electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. A properly grounded system can help to divert these surges to ground, protecting the equipment from damage. Grounding is a complex topic, and it is important to understand the principles involved. If you have any questions about grounding electrical systems, consult with a qualified electrician. They can provide guidance and ensure that your system is properly grounded. Remember that proper grounding is essential for electrical safety and for the proper operation of electrical equipment. It is a critical part of any electrical system. Following NEC standards is essential for safe electrical work.